Okay guys, today I will show you how to calculate rainfall pause in Senegal. So let me share my our code that I have developed today. So, entire screen share. Okay, directly to the point. So this is what we want to do. We want to calculate rainfall pause in Senegal, which means we want to see during the wet season in Senegal, how long is the rainfall is stop, for maybe for 2 or 3 days, maybe 4 to 6 days, or maximum days. How long does rainfall stop during wet season? So here we make a calculation where we want to define the start and end date of the wet season first. We need to identify for each grid point of the CHIPS dataset, when is the start and end date of the wet season. So we define that that okay okay we define that the start date of the season defined as the first day of rainy period of 20 millimeter or more over 3 consecutive days. So without any interruption by dry period of 7 days or more in the following 20 days. So the start date we define by this one. And then the end of the rainy season we will define as will be identified when there is no rain of 10 millimeter for 20 consecutive days. Okay, to do that, we need load the required package first, library dplayer, and also library tidyr, and then set our working directory with our this in this case we use chips rainfall dataset. So put your folder address here, and then also your chips dataset is here. So this is how the chips dataset is arranged. We arrange it as year, month, and day. And then the grid point. We have 263 grid point. So arrange the data like this. Year, month, and day, and then for each grid point from 1981 until 2019 here. This is the data that we have. So first arrange the data like this. And then we read our dataset. And then we combine the year, month, and day into a single date column. We combine it into year, month, and day like this. So if you do a view function here, you put that, you will see that your data set will look like this. Oh, it's, it's loading. Okay, year. If you look at the end, there will be year, month, and date. Okay, here, that you see, if it's not appear, you can just direct this one, and then you can see it arrange the date like this, because this is how R can easily understand the arrangement of that year, month, and day. So, and then we combine that year, month, and day into a single date column. We already did do that one. And then we find the season the season dates by using function rainfall. So we first initialize the result. This here we do the loops. We start at is NA, and that is NA. So we do the loop for each day to find the start of the season. For length rainfall is 22. Check for 3 consecutive days with more or equal to 20 millimeter total rainfall. If some rainfall is more or equal to 20 days, check the following 20 days for no 7-day dry period. So next 20 days rainfall, and then it will iterate here, dry period for next 20 days. If all dry period, and this is all the definition for the start of the season. for 20 millimeter of rainfall of more than 3 consecutive days without any interruption by dry period of 7 days or more in the following 20 days. And then we find the end of the season after the start date here. If it's not, you just follow this code, and then it will calculate exactly the end of the season is identified when there is no rainfall of 10 millimeter for 20 consecutive days. It will calculate. If there is no rainfall for 10 consecutive days, of 10 millimeter for 20 consecutive days, and then it will break. And then it will return all the list here for start date and end date here. It will make a loop for 263 grid point just now. And then we apply the function to all the grids and years. So the result, we use the pivot longer function. Column starts with V because we want to calculate all the V, right? All the column. And then all the grid point value with the rainfall, and then we group it, and then we summarize the result here. We follow this code. Start date from 1980, 1981, and end date, something like that. And then you save the result as season date. So I already run this code, and then I have this season date. So all you need to do is just run all this code just now from the beginning until the end here, and then you will get the result, season date here. So as you can see, for each grid point and for each year, it will give you start and end date based on this definition just now. So each grid point, and each year. So you can see from 1981 to 2019, the start and end date is different every year, even for the same grid point. So every year there is monsoon season or something like that, wind speed or something that large scale climate phenomena that influence the rainfall over there in Senegal. So the start and end date can be different for each year. So for each year, for each grid point here, we calculate when is the start and end year of each of that grid point. Okay, this is the result. So because that kind of data is very difficult to understand, so we visualize the start and end date just now. So to visualize that start and end date for each grid point and each year, we use library ggplot2. We use ggplot2, and then library dplayer, and then use the result just now, the result that we have, season dates, and then we convert dates back to date type here, and then create a column for the duration of the rainy season, and then we run this one, and then we ensure that the grid is treated as a factor for discrete axis, so from V1 until 293. And then we visualize by using heat map of the season duration. So this is the heat map. We use ggplot. For x-axis will be year, y-axis will be grid. We have grid V1 until V263, and then fill will be season duration, the duration of the rainy season. So we put yellow as the color for low rainfall season, and dark blue as when the season duration is longer. So the color will reflect the season duration in terms of number of days. So we use scale X for continuous break from minimum to maximum, and we make interval by 5, so every 5 years for X just now, which is for year. And then for y-axis, we put from 1 to V1 to until V293. And then we make interval of 10, something like that. So we have the title will be heat map of rainy season duration for the year with 5-year interval. And then the grid will be from V1 until V293 with interval of 10. So fill will be the season season duration. So you can follow this code here: exist text for x y, and the legend position. So when we run this code, we visualize that you can see we visualize the duration of the wet season in Senegal. So on the y-axis is the grid, different area, and the x-axis is the year. As you can see, V1 here or up to V11, the duration of wet season is quite longer, compared to some other area that have a shorter rainy season. And some year we can see like in 1996, maybe this is during El Nino. I don't know over there. What do they have in Senegal? There's very wet season is very short, very short wet season. And in 96, 7, 8, 9, I think 1999 wet season is very high. Is very long, not very high, very long. In 1999, you can use this one, put into your paper. You just copy as bitmap and then copy into your paper, and you can show this to show how long is the grid, how long is the wet season. But some year is undefined because it doesn't fall into the criteria of this just now. So we strictly use this criteria, but so some area is like gray here. It doesn't seem to give the wet season is indeterminate. They cannot determine. So now we already have that plot just now. Now I will export that plot to get the season length by using library dplayer. So get the same result just now, season dates, and then we convert dates to date format, result, start date, result, end date. Here, use this code. And then we calculate season length in days, calculate the season length. And then after it's calculated, it will give you season date with length. So we just now we have start and end date, right? Now it will give you how long is that wet season. Here you can see it gives you how long is the wet season, something like this. Some area have very long wet season, up to almost 150 wet season. Some area is very low, something like that. So it gives you the length of the wet season. That is what we export, the data that we export. Otherwise, it can be visualized by using this heat map just now. Now we go next for intra-seasonal dry sequence with 1 millimeter threshold. So for this one, we want to, I don't know. Let's see. We want to identify a certain category of dry period during wet season. So we make 3 definition here. We have 4 definition, which is during that during that rainfall period, there will be a 2 or 3 days dry length. How many times it happened during the wet season? Or another category is 4 to 6 day. Another category is 7 to 15 day of consecutive dry period, that which is less than 1 millimeter. And then also another one is maximum sequence. How long is the max of dry period that ever happened during that rainfall season? This is what we want to calculate. Also, we calculate by using library dplayer here, library dplayer. And then we read our original data set just now. which is this one, chips rainfall. Make sure it's arranged the same year, month, and day. Doesn't disturb the original dataset that we used from the beginning. And then we read the rainfall rainfall data, and then also we read our season dates with length. So we have season date with length that we already calculate just now. You will have this output that have the grid year, start date, end date, and also season length. So by using these two output, we will calculate intra-seasonal dry sequence with 1 millimeter threshold. So this is convert that to data type first, and then we initialize an empty data frame to store the result. This because we want to do the loops, and then we loop through each grid and year for I in one and row season dates, grid season dates, grid year. You can follow this code, and then we filter rainfall data for the current grid, year, and wet season. So rainfall year, start date, and end date. And then we identify dry sequence where its rainfall is less than 1 millimeter. And then this is the argument here. Make sure that it's 1 millimeter. And then we count the consecutive dry day. So we extract only dry days with this kind of sequence. First, 2 or 3 days, 4 to 6 days, 7 to 15 days consecutive rainfall, and then also make sequence. So this is the argument that we write. And then we append the result, dry sequence result, using our bind. Now, use dry sequence result, data frame, grid, year, count, this and all these categories that we have. And then you can just run the all of this code, but I will not run it here because it takes quite some time to finish. And then you can export your result here. Result. You can put any name that you want, and then you will get this kind of output. So this is the output that you will have. Grid, year, the first category, second category, third category, and the max sequence category. So you have 4 categories. You can see there is the occurrence of 2 to 3 days dry period during wet season is 14 times. 4 to 6 consecutive dry days, it's occurred 3 times during this year at grid V1, something like that. And max sequence, the longest dry period is 5 days. So we understand this one, right? So you can run this code and then export this data as CSV file. And then we doesn't stop there. We map the result. So everything, you don't need shapefile or whatever. I do this just by using R. And then how we are mapping, we map the mean annual dry sequence for each of that category. Because when we want to do mapping, usually we make the mean for the whole year, for the whole period, for each area. So actually, I'm not calculate the mean here. Actually, map total annual dry sequence of each categories. Actually, I recalculate this one again just now. I use the sum instead of mean because we want to calculate the total from 1981 to 2019. How many times that certain categories of dry sequence is happening, so that we can understand which area is more affected by rainfall pause during the wet season. So for this purpose, we use dplayer, ggplot2, SF library, R natural earth library, R natural earth data library. If you don't have this library, please install this first, and then it will good to go. So we read our data set, which is from previous one, the intra-seasonal dry sequence with threshold 1 millimeter. So we use this input data set. This input data set for mapping. This is what we get from the previous calculation. So read the data set, and then we aggregate, we calculate the total, not mean, calculate the total. This will make more sense rather than mean, because we want to know over the years how many times the dry period happened during that rainfall season in certain area. We count for 2 3 days, for 6 days, 75 for each of these category. So and then this is what we use for our natural earth library. We use country Senegal. Country for Senegal for the shapefile. We create example grid coordinate. We replace. Oh, this is actually we have grid point here, right? But this one they use random coordinate within Senegal. So I need to revise again this code actually. But I will give it later. I just just noticed that I didn't change this grid point with the original grid. We have this grid for Senegal actually, which we should use for the grid location. This one actually it's use random grid. But anyway, by I will show later how we can map this threshold. But it will show you something like it will plot everything. We run everything, but it will show you a result something like this. But you see it random. I should put the let long for. No wonder it looks weird, because just now I thought that only the drops that happen is appear. I just noticed it was actually a random plot. So I need to change this one with the original let long later on, and then we will get a better result. So more or less, I will map this, and then I will give it later, maybe tomorrow. So actually, it will give you a very good plot actually for this one, for categories 2, categories 3, drive sequence, and also for maximum sequence. Okay, I will give this result maybe tomorrow, uh, or maybe later after this, because I'm free. I think that's all for today. Thank you.